Okay, so today I'd like to introduce you to some stream table vocabulary, and our stream table unit is a quick one, and it only has one standard. And the standard that we're going to be working on says this, that it is actually assessing your ability to examine a landscape and determine what force shaped that landscape. So that's the question we keep asking again and again. And so you're going to be seeing and designing actually but a series of labs, one is an exploration, and two of them actually are explorations, two of them are true experiments, and then you're going to just design your own. And this vocabulary will come alive during those explorations. So it's important that you're familiar with the vocabulary today, and also that you're working to study it. I have posted a Quizlet with this so that you can practice. So let's go ahead and get going on it. So in math, you've been working on this concept of slope. And so the science word for slope is gradient. So the slope of a stream channel is the gradient. So if you look at this hill, if a stream is running down a hill, well, this is the rise, which would be like your change in the y, and this would be your run, which would be your change in the x. So again, gradient in one word means slope. Now this one is very closely connected to speed. So the discharge of a stream, and sometimes you hear it called discharge rate, is the amount of water moving past a certain point in a certain amount of time. So I picked this picture because you notice the arrows and it says velocity, which is speed in a direction. So that is really similar to discharge. So basically how fast the water's moving. Now this you're going to see again and again. So an alluvial fan is how you say it, alluvial fan. So alluvium is a synonym for sediment. And of course, sediment are those little chunks of rock. And so when you look at this landscape picture, do you notice this kind of triangular shaped fan? Okay, so what's happened is the sediment has been eroded down, down, down from that stream channel and has been deposited in this fan shape. So you'll definitely see those. Now, this next one, a delta, this is a type of alluvial fan. So it's an alluvial fan that's created when a river hits the ocean. So this is actually a satellite image. And so this part right here is not the delta yet. That is actually the river. And then this is the delta. But do you see how it looks similar in shape to this alluvial fan? It's just the alluvial fan when the sediment hits the ocean. And of course, we know that's where those chunks would start to be cemented into new sedimentary rock. Okay, our next one is a kind of fun one to say, meander. And so if you keep your eyes open, you will notice meanders in streams and rivers around here sometimes. So a meander in one word is a bend. So this is a meander or a curve in the stream channel. And we'll be exploring with what conditions actually create meanders in a stream channel. Here's a more familiar term to you, canyon. So a canyon is actually shaped like a V, and in this case, it is a very deep V, and it's been cut by a stream or river. But you might be like, well, Mrs. Fickus, there's no stream or river there. Well, do you notice this V shape? That tells us that liquid water had once upon a time flowed through there and done the carving. So what about the difference here? So we see a V with a canyon. Now notice this, a glacial valley. We don't see a V shape anymore. Instead, we see a U. Now, I know it's not quite as high on this side, but that is more of a U-shaped valley, and that tells us glaciers. So the rest of the terms are related to glaciers or erosion by ice is how you can think of it. Okay, so a couple years ago, I had a student pronounce this moron. That is not how you say it. Terminal moraine. So moraines are deposits by glaciers, and here's what I want you to think of. Glaciers are super powerful. They move, sometimes slowly, but they can move and bulldoze great amounts of sediment. So all of the sediment you see at the end and along the sides of this glacier have been eroded from further back in the mountains here. So terminal moraine means the end deposit. So where I'm wiggling the cursor here, that's the terminal moraine. So what about lateral moraines? Those are the glacial deposits along the sides. And so in this picture, the glacier is still here. But if the glacier would melt, we wouldn't have to wonder if a glacier was there. We would be able to tell because these moraines, these sediment deposits would be left to let us know where the glacier used to be. Okay, so here it is again. Terminal moraine at the end, lateral moraines along the side. Okay, so this next one is a kettle lake. And actually, sometimes they are not lakes, they are just called kettles. And so here's the deal with them. They are really not exactly left just from meltwater. So sometimes you get a lake at the end of a glacier, just a normal lake where we've had the glacial melt. But check out the difference here with a kettle. So this is an airplane view of some kettle lakes in Minnesota. And maybe you've heard Minnesota called the land of 10,000 lakes. They're usually not very big. They're these kettles from past glacier times. So let's look at this progression. So sometimes a piece of ice breaks off of a glacier when it's, especially when it's melting back, and then that ice can actually, because it's heavy, sink down into the rock layer or the soil. And what ends up happening is this ice can melt and it leaves what's called a kettle. Now, a kettle would be like a big cooking pot. So you can see how, if you really look at it, it makes this depression that kind of looks like a kettle. Now, here's the thing that can happen. Sometimes the kettle fills, and it all has to do with where the groundwater is located. So it's not that it fills so much with glacial ice melt as if the water table, it's called, the level of groundwater is above where that depression is, that kettle, then you'll get a kettle lake. Okay, so the kettle is the dry, it's this part where it's dry. The kettle lake is if groundwater, basically like spring water, fills it up. But the whole thing was created from a chunk of ice breaking off the glacier and being heavy enough to cause that. Okay, now this next one has its origin in French. So you don't pronounce it cirque, you pronounce it with just one syllable, cirque. Here it is again, ready? Cirque. And do you notice how this is like a bowl shape? You can still see glacier in there, but once upon a time that would be full. And so these cirques are characteristics of glacial erosion also, because the heaviness, the weight of the glacier creates the cirque. This one is much easier to pronounce. This one is a horn, and this is a beautiful picture, I think. But here's the story. Glaciers, multiple glaciers, have met on all sides of this horn. And the reason the horn is so pointy is the glacier has literally stripped away all the sides of the mountain, just leaving this little bit of mountain left to create a horn. The last couple of terms are also related to glaciers. This one also has a French origin. You pronounce this one arete. Here it is again, arete. Okay, so an arete is right here. This is highland between two glaciers, and in this case, you can see the glaciers. Sometimes students will say, Mrs. Fickus, that looks like a highway. It's not a man-made highway. This is a natural glacier. And then check out this picture. This is also an arete, and you're like, huh, I don't see any glaciers. Well, they've melted, but the present is the key to the past. If I see an arete in the present, I know that there were glaciers on each side. And I think I've saved the best for last. We definitely can see these in Ohio. These are called erratics. And so here's the deal. You know how glaciers can bulldoze and push sediment and make those terminal and lateral moraines? Well, another thing that they have in them is they have sediment embedded in them, and they can be huge chunks of rock. Well, when the glacier melts back, it drops those sediments. And so here's the deal with an erratic. If you were walking in the hallway, say erratically, you'd be walking crazy, right? Like making a spectacle of yourself. Erratics are also crazy because they're out of place. Most of the time, they are not even the right rock type for the area. And sometimes, look at this picture. This is actually from erratics in England. Sometimes they leave these interesting rock piles just based on what sediments were in the glacier and how the glacier melted. So I definitely want you to be using your Quizlet, and you can use this presentation, just clicking back through and looking at all the pictures to master the vocabulary. The test that's coming in this unit has a vocabulary section and a picture analysis section. And so honestly, if you don't master the vocabulary, the best you could get on the test would be a 2, and that is not even passing. So you want to make sure that you work with the vocab.